And we wanted to take a quantitative approach to that. So the first step was to look into machine learning approach. And so we put together a standardized imaging rig with a camera that was pointed down onto a static background, and we imaged uh, a set of several hundred cocoons at standard height, standard lighting, and we extracted the visual features from the surfaces of those cocoons. So we got their dimensions, we got the average color, the aspect ratio, and we used all of those visual characteristics as the inputs for a machine learning classifier.
From the Oregon State University Extension Service, this is PolliNation, a podcast that tells the stories of researchers, land managers, and people like you who are making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Associate Professor of Pollinator Health in the Department of Horticulture. I know many of you are mason bee enthusiasts or producers, and depending on where you're located, you probably already know there are exotic bee species that may nest side by side with the native species that you are trying to propagate, finding their way into your cocoon returns at the end of the season. Now, while the adults of these exotic species are distinctive looking from the native species, their cocoons can be hard to tell apart, which means they can accidentally be propagated, or if you're shipping cocoons, shipped into regions where those bees aren't currently. This week, we talked to the author of a new paper that describes yet a new species of exotic bee you might find in your nest blocks, not from Asia, but from Europe. Michael Getz is a master's student in Tim Warren's lab at Oregon State University, and his paper, which was just published in Environmental Entomology, documents the discovery of the European mason bee, Osmia cornuta, in Vancouver Island and the lower mainland of British Columbia. His thesis in general focuses on non-lethal sampling of bees using advanced computer vision technology, but in this paper he uses this technology to see if he could develop a computer vision method to tell apart cocoons from mason bees of different species. In addition, he looked at the distribution of the bee in Europe and modeled it with biogeographical correlations here in North America to figure out the potential spread of European mason bee across North America. It is a wonderful paper. It's so comprehensive, and you can actually access it through the show notes because it's been made open access publication. So without further ado, let's head deep down the cavity of exotic cavity nesting bees this week on PolliNation. Hi, Michael. Welcome to PolliNation.
Hey, Andoni. Sorry. This is very unprofessional of me.
We
Should be able
love. How are we doing?
to,
This is looking good. Quality check. Okay, that's good. All right, let's try it one more time.
yeah.
All right, Michael. This is it. Welcome to PolliNation.
Thanks so much for having me, Andoni.
I'm really excited that you have a new paper out. I'm an author, but I did very little work. But this is a really exciting initiative, and it's at the heart of this paper are these observations of European mason bee that kind of anchored the paper. Where were these European mason bees found, and under what circumstances?
Yeah, so there were a couple different sources actually. The one that first came to our attention was a beekeeper up on Vancouver Island in British Columbia. Gave us a call because he found some fuzzy red mason bees hanging around his nesting blocks that he had never seen before. And so he had an inkling that it was a different mason bee, but he gave us a call and ended up sending down some cocoons from the nesting block that he had observed the red mason bee flying around. Um, and so we received those cocoons, dissected them, and confirmed that they are in fact Osmia cornuta, the European orchard bee.
Hmm. All right, so that was one observation, but I think you were telling me earlier that there were other observations, not by mason bee producer, but and earlier observations that were captured on this really popular science application, a phone app called iNat.
Right. Yeah. So there were,
iNaturalist.
yeah. So, right, the beekeeper's observations were backed up by multiple iNaturalist observations. The earliest one in the timeline was in spring of 2023, made in North Vancouver on the mainland. And there have been multiple observations on Vancouver Island made by other folks that are related to the initial beekeeper. But all of these observations on iNaturalist were made by participants in the British Columbia Bee Atlas program. So they are trained volunteers who have an eye for bee identification.
This is a great story. I just love that, I imagine exotic bees are always being introduced to the United States and Canada and probably go unnoticed for decades until they really spread. But having them detected, perhaps, we don't know exactly when it was introduced, but probably quite soon after it was introduced, probably is a testament to a growing interest and competency in being able to discriminate between bees.
Exactly. And it really shows the value of folks that have this interest to, go out and uh, get trained in bee identification, which is not exactly everybody's cup of tea, not exactly the easiest hobby to get into, but really impressive that they were able to single out these bees and publish public records of them.
Well, I suppose there's also a very large group of people, especially here in the Pacific Northwest, who are into mason bee culture and are rearing Osmia lignaria. For those people, what roughly are they looking for? You said it was red. Is it the same size as the blue orchard bee? What Tell us a little bit about this critter.
Yeah, so it's just a little bit bigger than Osmia lignaria. There's definitely a lot of overlap in the different sizes between the two. But its characteristic quality is that it has a fuzzy red butt. Um,
Okay.
and it's kind of great, or something that's kind of great about mason bees is that as adults, they are pretty distinguishable from one another, especially the ones that tend to cohabitate in similar regions.
Well, I suppose this is kind of the flip side of this is maybe the adults are identifiable, but I imagine cocoons are maybe not so identifiable. And you were really interested in this question of whether somebody who is raising mason bees could discriminate these cocoons from the bees that they were dealing with, as well as other exotic species. Can you explain how well, I guess for people who don't raise mason bees, how these cocoons are moved around and how you kind of assess this risk that a cocoon from an exotic species might get mistaken for a native species.
Yeah, so a common method for mason bee rearing, or maybe it's the only method, it's the one that I'm familiar with. Um, so beekeepers will use nesting blocks, typically made out of wood with holes drilled in them, to entice mason bees to make their nests in. And once the nests have been built by the parent mason bees, and the cocoons have formed inside of those nests, they will open those blocks up and then scrape out all the cocoons, and they'll do some coarse cleaning usually, to get out the mud cap fragments, or sometimes there'll be a gentle bleach solution to kill anything that's hanging out on the exterior of the cocoons. And then those cocoons that they can just be boxed up and shipped anywhere in the country, anywhere in the world, really. And there are few regulations in general on where cocoons can be shipped. It's difficult to ship them over international lines, and there are some states that have restrictions on shipping non-native bees of any kind across state lines. But in general, a lot of states can be pretty lax about them. So there's not a ton of control that goes into managing exactly which species are being shipped around by mixed feed producers.
And I think it's important for Oregon listeners to know that the Oregon Department of Agriculture does a great job of this and is one of the few states with an approved invertebrate list. And bee, especially mason bees that are not found in Oregon already, are prohibited from being brought in. So check it out, Oregon Department of Agriculture. They have, I'll put the link of that list in the show notes. But okay, so Michael, there is this risk of these cocoons. You have a block, as you described, and multiple species nest in it, and you're not watching to see if the bee's going in and out. You come back, you see these mud plugs, you strip the cocoons out, and now you're left with this predicament of like, can I now, at the sorting stage, sort out the species that, I don't want to move around outside my region versus I do? How did you figure out whether this is a doable practice, whether somebody visually looking at these cocoons could tell them apart?
Yeah, well, some interesting data that we got was when there was an initiative to sort of look into mason bee health throughout the state of Oregon, and so a lot of hobbyist or amateur beekeepers were sending in cocoons to OSU, and they would label them multi-species. And so we had the opportunity to go through this backlog of cocoons and dissect them and figure out exactly what species were inside. And so that gave us sort of a rough estimate of the, the feasibility of determining which species was in each cocoon. And, and I should say too that the initiative wasn't specifically about, determining cocoons by species. It was, so it's not as though these volunteers were tasked with this, determination. But we found that the cocoons that were submitted were identified with about 79% accuracy. And, just anecdotally, folks who work with mason bee cocoons a lot, either through research or through the beekeeping practice, have reported that it's just incredibly difficult to tell them apart. Some folks say that they have more ability to do it than others just after looking at thousands and thousands of cocoons. But there still just seems to be this sort of intuitive gestalt impression that people are, basing these determinations on. Uh, and so we're interested in finding out what sort of basis there is for discriminating uh, cocoons by species. And we wanted to take a quantitative approach to that. So the first step was to look into a machine learning approach. And so we put together a standardized imaging rig with a camera that was pointed down onto a static background, and we imaged uh, a set of several hundred cocoons at standard height, standard lighting, and we extracted the visual features from the surfaces of those cocoons. So we got their dimensions, we got the average color, the aspect ratio, and we used all of those visual characteristics as the inputs for a machine learning classifier. Um, and
Wow.
the machine learning classifier was able to outperform the human classifiers just slightly, but it still struggled with some cocoons or some species over others.
So in practice, then, it seems to be, even with technology as an aid, to really 100% discriminate between the cocoons. There's always going to be some that may slip through a sorting line, raising this issue of their potential spread through the trade of cocoons.
Definitely. And I have to qualify this effort by saying that it was rather simplistic in the grand scheme of the technology that's available and the technology that's continuously being developed.
Ah,
And we have even made some inroads into developing a more complex approach to it using deep learning techniques, computer vision techniques that folks may be familiar with, um, which is just sort of a more advanced machine learning approach that uses just every available visual characteristic rather than the human operator deciding which visual characteristics to select from the image. Um, and so,
Hmm.
with a larger data set, with a more representative collection of cocoon images, we think that we'll be able to improve those results. But we're still pretty far off from having something that's reliable enough to, process millions of cocoons on an assembly line before they get shipped out.
Okay. So it is up. It is possible. The technology really, you just kind of did a first pass in the paper of trying to use the technology, but as you point out, that you are kind of, your own prejudices were sort of cast on this in a deep learning program that really, doesn't even, it has its own kind of rubric, may be able to do this in the future. But right now, I suppose we are at a situation where there may be cocoons in the cocoon supply line that are leaking into places where these bees are not currently. And you were really interested in the question of, if that were to happen, you know, where might these bees establish? Knowing their distribution, I suppose, in Europe, you should explain the methodology, but that you might be able to say, oh, this Arizona, a cocoon that ended up in Arizona may not be likely to spread. Tell us how you did that. How did you figure out, what the potential range of this bee might be in North America?
Yeah, so we took an approach that also leverages the advantages of community science, where in Osmia cornuta's native range in Europe, there's just an enormous amount of uh, observation data, and so we use that body of data to um, put together a sampling of locations where it has been observed in its native range. And then we used a climate data set to figure out what sort of the range of conditions are present in Osmia cornuta's native range. And then we compared that range of climate conditions back to the full range of climate conditions that are present in North America, and
Uh-huh.
then just found which regions in North America are within this climate
Wow.
niche of Osmia cornuta in its native range.
Oh, amazing. Oh, great. And so you can look at all of these. I mean, it's kind of like the cocoon identification. You don't know what all the variable, which the most significant variables, but when you sort of like relate them to North America and precipitation and elevation and all of those things, you can come up with a map. Well, tell us what the map looks like. In rough sketches, is it going to be everywhere in North America all at once?
Uh, Not quite everywhere. There's some relief there, but it did identify the areas where it was first detected. In the Vancouver Island, Vancouver, mainland area, and you know, down into Washington, along the Olympic Peninsula, and then down through the Willamette Valley, as well as some areas in inland Pacific Northwest. But then well, and I guess to stay on the West Coast, the California Bay Area was another hotspot. But the strongest and broadest continuous region is all in sort of the mid-Atlantic, spreading uh, outwards or just sort of radiating outwards into the Midwest and the northern end of the Southeast states. Um, And these maps or this climate model that we produced looks really similar to the current ranges of two other exotic mason bees that were introduced from Asia. That's Osmia cornifrons and Osmia taurus. And those were both introduced to to Maryland, to the Maryland area, and within the past 20 years have really exploded in population and geographic range. So we would predict that if Osmia cornuta was also introduced to that area, then it would also flourish.
Wow. So having at least 3 exotic species in the mid-Atlantic, if it was introduced, kind of with a very great spatial extent that it could occupy. Okay, well, maybe just to conclude, tell us about these other species. I know I was just in Boise, and we have our first Western detection, which is put in the paper of Osmia taurus. So I do want our Boise listeners to be on the lookout for this exotic bee. But tell us about these 2 other Asian species.
Yeah, and I realized that earlier. I said that it's so great that it's really easy to tell adult Osmia apart, and these two actually look pretty similar to
Mm-hmm.
each other. Um, but they shoot, I'm trying to think of what
Well,
I haven't said yet. But
the thing I was going to say about them makes them kind of similar, and I know just being out here in the when we deal with blue orchard bees, they are a blue metallic color, and these ones have a kind of brown. They're they have a hairier body and it's brown. They are about the same size, and I guess you're the two of the and they both have horns. I can't remember.
uh,
Cornuta does have
I
horns.
I want to say yes, both of them. Yeah, Taurus does too. And I think that the extent of the protrusion is a helpful diagnostic
Ah,
characteristic.
so you may not know if you've got it, but I think what I'm getting from this episode is it's always great when you're out in a nice sunny afternoon and you see a mason bee on your flower in the spring that is not doesn't look usual. Snap a picture, put it on iNaturalist. It seems like it's a great story of like people are looking through those records on a daily basis and may pick these things up.
Yeah, and there is a bit of nuance to interpreting where these detections show up because, especially when you have this artificial dispersal method through the cocoon trade, you could always have adult bees that arrive in an unfamiliar habitat and they survive for the year, but they don't successfully reproduce. And, somebody may snap a photo of that bee just before it
Right.
dies or something, before it establishes a population. So
Mm-hmm.
just the presence of a record doesn't necessarily mean that it has established there. So the more records we have, the more confident we can be that a certain bee has established in a certain area and is actually expanding its range.
I had a conversation recently with somebody, a research scientist who was really interested in mason bees, and I told them about the Boise iNaturalist records for Osmia taurus, and then they followed up. So you may get a call from a scientist who's interested in spread and dispersion, who can then do these follow up. Okay, go back out and let's see if it's persisting, or can you get some more records? I mean, it's I like the way that you pose that. It may not necessarily talk about persistence, but I guess hopefully you can reach out to somebody or they'll find the record anyways, and the follow up will ensue.
Yeah, exactly. And, especially with, as you mentioned, the growing popularity of sort of this backyard beekeeping and the interest in mason bees, if everybody in the Pacific Northwest who has a mason bee house in their backyard could be checking it every now and then and, notifying researchers when there is a detection of this really distinct red mason bee, then yeah, it helps researchers decide where to allocate resources and time and to go hunting for a particular bee.
And I would maybe add to that. I think that's a great suggestion. And in addition to that, I would say, if in doubt, contact your Department of Agriculture. They have entomologists on staff who are familiar with these issues, and they can really provide guidance on what you should do. Is it and perhaps follow up. So Anyways, this is great. This is a great episode. It's a great discovery. It's not a great discovery, but it is just the way that you've threaded these observations and into a kind of raising awareness of this introduced bee. It's really remarkable.
Oh, and I feel really lucky to just have had more interactions with the mason bee community because it's really discovered how many passionate folks are involved both in the beekeeping and in the research side of things. So it's really just a neat community.
Fantastic. And it's really great. The paper is open access, so we'll have the link in the show on the show notes, and people can take a look at it. Thank you so much for joining us today. We really appreciate you taking the time, and congratulations on your paper.
Yeah, thanks for having me on, and thanks for your time.
Thank you so much for listening. Show notes with links from each episode are available at the website pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's a form at the website where you can pop in and say hello and give me feedback. If you want to support the show, remember to leave a rating on iTunes, Spotify, or whatever podcast mothership you use. And finally, if you have the means and you want to help support my lab's effort to document bee biodiversity in Oregon, visit OregonBeeAtlas.org and follow down to the donate button where you can make a tax-deductible donation to the Jerry and Judith Paul Native Pollinator Endowment. Every little bit helps. See you next episode.